Hello friends, welcome you all. So in this lecture we will discuss one more mathematical model which is known as Pushdown Automata, and it is used to implement context-free languages. In short, you can call it as PDA. So first I will discuss the working of Pushdown Automata with the help of block diagram, and then we will discuss its mathematical definition, uh, which is including all tuples of pushdown automata. So I will start with working of pushdown automata. Suppose this is one PDA. It is one PDA, and this PDA reads one input, one symbol at a time from this storage, or you can also call it as a tape. So suppose this particular PDA is reading one symbol at a time from this storage, and this uh, head is called as read head of PDA. Read head of PDA. And PDA, after reading one input, PDA changes its state to another state and also perform some operation on stack. So after reading one symbol from the input, it changes its state to new state and also perform some operation on the stack. Now, if you can remember the working of finite automata reads one input symbol and it changes its state. And after reading complete string, if finite automata is in one of the final states, then string is considered as valid. Otherwise, it is declared as invalid. So PDA also gives us binary kind of output. So these output may be valid invalid, or 0 1, or yes no. So these kind of output may be given by PDA. And as I told you friends, like after reading one symbol from the input, PDA changes its state to next state and also performs some operation on this stack. So while reading one input symbol from the storage, PDA changes its state to next state and also performs some operation on the stack. So as you know, friends, most commonly performed operation on stacks are push and pop. Push and pop. And push means adding some element into the stack, and pop means removing some element from the stack. So whenever PDA reads one input symbol from the input, it changes its state and also performs some operation on the stack, which may be push operation or pop operation. And after reading complete string, if PDA is in one of the final states, then this particular string is considered as valid string of the language. Otherwise, it is considered as invalid string of the language. So here it is just like finite automata. It provides the valid string or invalid string. So this kind of result it provides. Now in case of PDA can accept strings in two different ways. So based on that, PDA are of two types. PDA accepting strings. First is PDA accepting strings by reaching final state. Final state. Now in this particular type, if after reading complete string, if the PDA is in one of the final states, then you can consider this PDA as PDA accepting string by reaching final state. And if the current state after reading complete input, if the current state of PDA is one of the final state, then this string is considered as valid. Otherwise, it is declared as invalid. Now, there is one more way to accept strings in PDA. This is known as PDA accepting strings by empty stack. So now in this kind of PDA, if after reading complete string, if the stack of associated with PDA is completely empty, then string is considered as valid string of the language. Otherwise, it is considered as invalid string of the language. So this kind of PDA is known as PDA accepting strings by empty stack. One important thing is there, if you can create any one of the in the PDA, then you can convert it to other type of PDA. Suppose for any particular language, you can create PDA which is accepting strings by reaching final state, then you can easily convert this particular PDA into PDA accepting strings by empty stack. And reverse is also true. Like if you can create for any particular language, if you can create PDA which is accepting string by empty stack, then you can easily convert into PDA accepting strings by reaching final state. So both type of PDA we will discuss in this playlist. So now one more important thing is there about PDA. PDA are used to implement all context-free languages. All context-free languages, and sometimes some context-free languages require some memory to store some value. For example, one very commonly used context-free languages CAN, BN, where n is greater than or equal to 1. So this is one example of context-free language. And here you can see we need to have same number of occurrences of A and B. So here after all occurrences of A, B occurrences of B will be there. So to store the count of A, or to store the count of occurrences of A, we need to store this the value of n somewhere in the memory. So to implement this language, we need to store the value of n somewhere in the memory so that we can have same number of occurrences of B. So this stack is used to store this value of n. So here stack is being used as a memory element in the PDA, which was not there in Finite Automata. So this kind of language can be implemented by PDA. As you know, context-free languages are superset of regular languages. So all regular language can also be implemented with the help of pushdown automata. Now we will discuss the mathematical definition, or you can say formal definition of PDA, which is including all tuples of PDA. So now we will discuss the formal definition of PDA. So suppose if some PDA is there as P, so this will have 7 different tuples. Now first is capital Q. So it is capital Q is set of all possible states of machine. Then next is sigma. Sigma is same as finite automata set of input symbols. Then third is gamma. So as we are using here stack also with the PDA, so sigma is set of stack symbol. The symbol that we will use to push and pop operation on the stack. Then next is delta. Delta, which is same as finite automata transition function. But here the transition function will be different from finite automata that we will discuss in very much detail. Then next is Q0. Now Q0 is single state. It is not set. It is single state, which is initial state of PDA. Then next is Z0. So like Q0, this is also single symbol, which is initial stack symbol. Then next is F. F is set of final states of machine. So in PDA also, you can have more than one final state. So F is set of all final states of the machine. So these are 7 different tuples of PDA. And if you can remember, all tuples of finite automata are also there in PDA. We have added 2 extra tuples here, which are gamma and z0. Both are related to stack, which is there in PDA only. Now we will discuss the transition function of PDA in detail. So as I told you friend, when PDA makes transition from one state to another, it considers 3 different things for any transition. So first is it considers the current state which is coming from Q. Then it also considers current input symbol which is being read by PDA. So it is coming from sigma. Then it also considers current stack top. So it is coming from gamma. So these 3 things are considered by PDA. Sometimes when we are reading input in PDA, we also read epsilon from tape. So we will also include here epsilon like this. So complete input would be sigma union set containing epsilon. So this would be the proper input and it is considered as input to the PDA. So these 3 things are considered for making any transition in PDA. Now this will give us new state which will be coming from Q, and then as I told you friend, we can perform any operation on stack while reading one input symbol. So this operation may be push or pop. Now in case of push operation, in PDA we can push more than one symbol at a time, but we can pop only one symbol at a time from the stack. So if we in case we are pushing more than one symbol at a time, then this would be one string of stack symbols, and this would be represented as gamma, clean closure of gamma. So clean closure of gamma represent a string of stack symbols. So in case of we are pushing more than one symbol, so this will represent that string of stack symbol. Now as it is clean closure, so this may be epsilon also. In the case this gamma star is epsilon, it means we are popping one element from the stack. So this is the complete transition function of PDA. I hope it would be very much clear to you, and in case you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you so much.